Can you talk about breeder reactors and how that could benefit the industry? Absolutely. But let's review really quickly what a normal commercial nuclear reactor does. The uranium that we have in nature, it's only got about 0.7% of the fissile uranium-235 isotope. And so in order for that to work in a nuclear reactor, we have to enrich that isotope to about 5%. So you've got about 95% of the uranium-238, which is not fissile, it's fissionable, but it's also fertile, and about 5% of the fissile uranium-235. Now, in the process of burning that uranium-235, some of the uranium-238 will absorb a neutron, and then that activated product will decay down into plutonium-239. So that plutonium-239 is also fissile, and it will start to replace some of the uranium-235 as a source of fuel in the nuclear reactor. Now, the poison from the fission products will eventually shut it all down, but a breeder reactor is actually able to do more activation of the uranium-238 than is being used in the uranium-235. Here's an example. I'll put the link in the paper. This one is a hyperbreeder. This is something that a student and I are working on, where if you use beryllium moderation in slab configurations, you can get hyperbreeding, so that you can actually get a breeding ratio of about 1.55. In other words, for every fissile atom of uranium-235 that you hit up, you're making 1.5 atoms of new fuel in the form of plutonium. And so a breeder reactor makes more fuel than it uses. And why that's attractive is that if you're doing recycling, you can start to do much more efficient recycling. For example, if you use the waste depleted uranium, when I mentioned that we have to do uranium enrichment, we get the fuel has to have 5% uranium-235, and then you end up with 95% uranium-238. But as a result of that, you get what we call depleted uranium. The waste product from that enrichment has uranium that's about 0.3% of the uranium-235 instead of the natural 0.7%. And so that depleted uranium, which is a waste product, could actually be used with a breeder reactor as fuel. So you can turn all of that uranium-238 into regular fuel in the form of plutonium-239 in a reactor and burn it and make electricity and make it much more efficient. I mean, we already dug it out of the ground, we already purified it, we already turned it into a fuel. You know, why not keep reusing it as long as there's energy there to do so? And so breeder reactors make the whole uranium fuel cycle far more sustainable, because not only can you start to reuse your fuel that you're already burning, but you can also fold in the depleted uranium. And so it's just a really attractive approach to make the uranium fuel cycle sustainable and environmentally friendly, more so than it already is. So thanks for that question. I hope that answered it. Have a good day.